Hello everyone, my name's Chris Chinnock. I'm the president of Insight Media. Insight Media is also partnered with Braun Consulting to develop Insight Media University. Today I want to tell you about one of the courses that we've developed for Insight Media University, and this one's called the Glasses-Free Digital Signage Displays. This course will be given at DSC, which will be held March 6th in Las Vegas, and as you see on the screen, the agenda has 4 different courses, all 90 minutes long with some demos. And so today I want to profile the glasses-free digital signage displays particular course. In the outline, as you can see on the screen now, we're going to first talk about the basics of 3D displays. We'll talk about ways to improve some of the deficiencies of these glasses-free displays, in particular improving the resolution. There are ways to improve the image quality loss, particularly in 2D mode. There's eye and face tracking technologies that we'll talk about. There's also architecture and image processing improvements that are moving along quite rapidly. Time multiplexing is an important new trend area. And then we'll also talk about some of the methods for optimizing the 3D viewing space. This is also moving along very nicely. And we'll also have a glasses-free product review at the end of the seminar. As part of this seminar, we'll also have some physical demonstrations within the classroom so you can actually see and we can illustrate some of the principles that we're going to be talking about in this course. So today I'm going to focus on just one of these little sections to give you a highlight of what you can expect in this course. And in particular, I'll focus on the optimization of the 3D viewing space and the evaluation of the AS3D display, or an autostereoscopic 3D display. So first of all, there are some hardware limitations for lenticular-based or parallax barrier-based displays. There are discrete viewing zones, in other words, sweet spots that you have to be in. These sweet spots repeat horizontally around the display as you move side to side. There are cycles of these sweet spots, and there are both horizontal and vertical field of view limitations as a result of adding the lenticular or the parallax barrier overlay to an LCD screen. Now, these limitations are defined primarily by the design characteristics of the lenticular or the parallax barrier. So they are, for the most part, fixed in space. Now, these can be custom designed to fit specific applications, but today you're, for the most part, picking a 3D display that has a particular viewing distance and viewing characteristics. Now, there are some ways that you can fine-tune this and optimize it through software options, and these are actually moving along quite nicely right now. So there are things you can do by readjusting how the pixels are placed, how the information is addressed at the sub-pixel level, and you can actually do some sub-pixel rendering to try and improve this also. There's optimization for moving the pixel positions based on your head position. These rely very much on using eye tracking or face tracking technology, but it can be very well optimized for both 2-viewer and multi-viewer applications at this point. The software can also adjust things that we're calling depth, volume, depth, displacement, and zone transitions. Depth volume is really the extent of what you see on the screen in terms of depth. In other words, how far in back of the screen is an object, how far in front of a screen is an object. Generally, with glasses-free displays, that depth volume is much less than what you will get with a glasses-based display. And that depth volume can vary for a glasses-free display by vendor. So some vendors have smaller volumes, some vendors have larger volumes. The trade-off with having a larger depth volume, however, is those objects that are far away or very near to the viewer tend to start to get blurry or out of focus. So there's a trade-off in increasing the volume that may or may not be acceptable for your application. This depth displacement refers to where this depth volume is relative to the screen plane. So you can push a lot of the content in back of the screen plane, which often makes a more pleasing 3D effect if you're going to be viewing it for a long time, or you can push a lot of it in front of the screen, which is sometimes more desirable for an advertising application. You want to grab people's attention, so you kind of want to poke them in the eyes. So having the ability to adjust that is very nice. And also the zone transitions, or the fidelity of the sweet spot. Sometimes you can implement what's called a multi-view display, so you can smooth out the transitions from zone to zone, which again makes for sometimes an easier way for the viewer to acquire the 3D image. All this stuff can be done with the content itself through processing, both in real time or pre-rendered. If you pre-render some of these optimizations, you'll get a little bit better effect, of course. So that's all for now. I hope I will see some of you at the course in Las Vegas on March 6th. So Chris Chinnock for Insight Media signing off. Thanks very much. Bye-bye.